Cavitation is a phenomenon that occurs when a liquid changes from a liquid to a gas. And it's a term given to the formation of vapor bubbles at the low pressure, which is below the vapor pressure of the liquid being pumped. The pump fluid changes its state from a liquid to a gas, and then further through the impeller, as pressure is applied, it changes back from a gas to a liquid. And it's very noisy. That phenomenon, the change of state, is very noisy. It sounds like ball bearings bouncing around inside the pump. It occurs because water at normal temperature and pressure is at 1 bar pressure, only requires 3 kPa of pressure to keep it as a liquid. So it's a very low pressure, and atmospheric pressure is significantly higher than that. We're talking about 100 kPa. Whereas at boiling point, we know that a water will very easily convert to steam if we're over 100 degrees centigrade, because that's boiling point, and it changes from a liquid to a gas. So we're all familiar with what happens with water. If we take it below 1 degree, it turns to ice, so it turns to a solid. So it's something that we're really familiar with. Water, it starts as a solid, ice up to 0 degrees centigrade. It's then a fluid till we get to 100 degrees centigrade, becomes a gas. So we're all familiar with that. And these are absolute pressure readings. You might remember we talked about the definition of absolute pressure earlier. We now know that means the measuring point is not atmospheric pressure, it's absolutely zero. The important points to remember are that a liquid will vaporize if the local pressure in that zone falls below its vapor pressure. Okay? So if we reduce the pressure of the eye of the impeller below the vapor pressure of the liquid, we will turn that liquid to gas. It's nothing to do with air. It's the liquid changing its state. When you turn a liquid to a gas, it results in a dramatic increase in volume. And you might remember, if you go back to your days of boiling a kettle, as soon as the kettle boils, what happens to the gas? It comes out of the spout of the kettle, doesn't it? That's because there's not enough space inside the kettle to contain the volume of gas that's being generated with the conversion of the liquid to gas. And it's a mechanism which vapor bubbles are formed. And again, going back to our boiling kettle, what do we see inside the kettle? If it's transparent, we can see it all churning around. That's because the vapor bubbles are forming at that temperature. So it all happens very quickly. In about 3 milliseconds, we can change from liquid to a gas. That change occurs at 2 specific points in the pump. Here's an impeller, and you can see that the leading edge of the vanes is damaged. That is where the liquid stream coming into the eye of the impeller actually changes to a gas. And that's where you've got this rapid expansion, and it's quite a physically disturbing phenomenon. As that gas goes through the impeller and we add some energy, because our impeller is adding energy, you remember from earlier sessions, we then go back to a situation where that gas changes back to a liquid. And that's like an implosion. And here you can see the damage partly through the impeller vane. That is where that circle is where the gas turns back to a liquid. And we've then got almost an erosion situation where that rapid collapse of the bubbles causes a cavitation erosion. So that's the damage that occurs as a result of cavitation. And you can see quite clearly that the damage can be catastrophic. I mean, the sort of damage that you can see from cavitation means that the component is virtually useless. You have to throw it away.